Welcome you all back to the class. Today we are going to discuss about the Nernst Distribution Law. So before to enter into this class or to discuss about the topic, so the title itself, it's very clear, distribution. So what is that? If I add the solid particle in the two different solvent, okay, that is the two different, that means two solvents which are immiscible or partially miscible, okay. For example, carbon tetrachloride in water, right, immiscible example of for the immiscible solvents, okay, two solvents are immiscible. So in that I am adding the third component, for example iodine. So that is possibly dissolved in aqueous layer as well as in the carbon tetrachloride layer. That means organic carbon tetrachloride is the organic compound, aqueous water is the another layer, aqueous layer and organic layer. There is a possibility of the adding the third component iodine is distributed in the carbon tetrachloride as well as in the aqueous water layer, right. So how much? The partial amount of the third component which we are adding is partially distributed in the carbon tetrachloride and partially distributed in the water layer, okay. So to explain this concept, how much it is distributed on both layers, we can get it answered from Nernst distribution law. Okay, we will enter into our topic. So distribution law or the Nernst distribution or partition law. Okay, here we are going to determine the partition coefficient. That means the distribution of the compound, the third compound is existing in the one layer, aqueous layer as well as the organic layer. So the partition law or Nernst distribution law gives a generalization which governs the distribution of a solid between two non-miscible solvents. That is the major important component or concept here. The statement of the law is, if a solid X, if we take the X, okay, the solid is the third component, is the solid particle is X, then distributes itself between two non-miscible solvents, that is A and B, at a constant temperature, and X is in the same molecular condition in both the solvents. There is no change in the molecular level. Then concentration of X in A and concentration of B, the ratio of these two is nothing but Kd. Kd is the Nernst distribution coefficient or partition coefficient, okay, where Kd is called as the distribution coefficient or partition coefficient or distribution ratio, that is the ratio between the layer A and layer B, or in our example organic layer and aqueous layer. So if CO denotes the concentration of solid in a solvent A and Cw is the concentration of X in solvent B, then according to Nernst distribution law, how can we express mathematically? CO by Cw is equal to, we can get distribution coefficient, right, that is Kd. What are the applications of the Nernst distribution law or this partition law? So few examples I have noted over here, I have shown here. The first one is solubility of a solid can be measured or we can do the extraction, okay. Then the second one is about one substance can be extracted from the solution containing various substances. I have many number of compounds are existing in the solution. Using this distribution law or partition coefficient principle, we can take it out or extract the substance, particular substance. The third one is about used in high performance liquid chromatography. We are using in the HPLC the same principle, Nernst distribution law, to separate the compound. The another one is, it is useful in partition chromatography, and we are using this release of drug from dosage form for that purpose, because various compounds are existing in the dosage. We can able to separate out one particular compound using this distribution coefficient, Nernst distribution law. The last one is about passage of drug through membrane from one particular place to another place. That means that compound are distributed through membrane. That is also possible, or we can able to understand that diffusion based on the Nernst distribution law, because that when we are taking a drug, that will enter into our body and will cross many biological barrier and many number of membranes and enter and reach the particular target to dissolve to solve the particular disease, okay, or particular problem in our human body. So that's for that purpose the distribution law is very much important, helps us to understand the barrier diffusion. Okay, this is all about Nernst distribution law. Okay, the next concept is about solvation. What is solvation? Solvation is nothing but solid molecule get stabilized in solution. Okay, after dissolved in the given solvent, that solid particle need to be stabilized in solution with the help of how it is stabilizing with the help of solvent molecules. If I take the solid particles, these are surrounded by solvent molecules. The solvent molecules are continuously interacting with the solid particles. The solid particles are get stabilized though it is dissolved in the given solvent. So if solvation occur due to water, then the process called hydration, because H2O, hydroxide, right? H2O, that means hydrogen and oxygen. So that is called hydration is the another, but it means we are adding the water, that is called wateration or hydration over here. The next, solvation is quantified with respect to rate and the measuring unit of solution in mole per second. Okay, the unit for the solvation is mole per second. Okay, the next, for example, if you take ion, sodium ion solvated by water molecule, I am just shown in the picture, sodium are surrounded by water. For molecules, for example, sucrose, non-electrolyte, or glucose or glycine is the amino acid, those things are solvated by water with the hydrogen bonding formation is called hydration. Even if you take glycine betaine is one of the best example in the time of protein, wherever it is lacking of water, if you add the glycine betaine, that carries some amount of water because of the stability of the glycine betaine due to solvation or due to hydration. Whenever the protein required, the glycine betaine can give some amount of water to the protein and protein gets stabilized. This is the applications or uses of the solvation, and it is called as some of the scientists and the literature people talking about the microsolvation. Okay, we are going to see about this solvated water molecules with the compounds are responsible for stability of the structure. Yes, if any compound, for example, glycine want to stable, it won't stable in the gaseous phase. It is always stable in the water environment. If you remove the water, the gas, that particular glycine molecule will be dissociated. Okay, example, hydration of sucrose or hydration of glycine. These are the hydration process or solvation process, increasing the stability of the solid particles or increasing the stability of electrolyte compound. Okay, so the next one is association. So what is association? So association is chemically, if you speak, association is a phenomenon in which opposite electrically charged ions comes together in a solution to form a separate chemical entity is called association. Okay, if you speak in terms of theory, here this Coulomb's law explains the association. What is the formula as per the Coulomb's law? F is equal to K into Q1 Q2 by R square. The F is nothing but force of attraction between the two ion pair, and Q1 Q2 are magnitude of electric charge. Then the separation between the particles is the two ionic part, the separation is radius represented by R. Okay, the Coulomb's law describes the force between two charged particles based on the force of attraction between two ions help to calculate the association. You can see here I just shown three kind of association, ion association particularly. This is the first picture is about the fully solvated. This is standing in between there is some space between the ions, right? Fully solvated, that is a green color. The next one is solvent shared or solvent separated ion pair. The third one is contact ion pair. These are the three types of ion pair formation existing in the association. So what are the factors affecting solvation and association? So solvation affecting by surface area, and if you do the stirring process or if you heat it up, the solvation will be affected. The another one is association. Here due to the surface area, there's magnitude of electric charge, and dielectric constant of medium and distance between ions. These are the factors. If you increase or decrease, the association will be affected. Okay, these are the topic about the association. Okay, the next topic is about diffusion principles in biological system. What is called diffusion? If I have the compound solubilized in the given solvent, that solid particles can travel from one place to another place, right? If I have the solution, it will travel from one place to another place. I have the barrier over here. This solid particle can travel. How it will travel? If the concentration is high, here concentration is low, then the diffusion will be happen from higher concentration to lower concentration. There is a not possibility of lower concentration to higher concentration, is not at all possible. Only the possibility of the diffusion is higher concentration to lower concentration in biological system. So diffusion is defined as the process of mass transfer of individual molecules of a substance from one place to another place. There is nothing but higher concentration to lower concentration. Molecules are in random Brownian motion. What is the Brownian motion? In the liquid place, the solid particles are moving here and there without any kind of direction. So that is called Brownian motion. Okay. So they move more readily from a higher concentration to lower concentration. That is concentration gradient. From moving the higher concentration to lower concentration of the diffusion of particle is called as concentration gradient. Okay. So the passage of solid molecules through a barrier may occur by simple molecular diffusion or permeation. Okay. The another one is by movement through pores or channels. In the biological membranes, a lot of pores and channels are available. Through that, the solid particles will migrate and move from one place to another place. That means higher concentration to lower concentration through these pores and channels. Okay, in pharmacy, diffusion of drugs through a barrier is important. It's very important. If there is no drugs going through this barrier and to reach the next level, then that we cannot treat any of the disease by the given medicine. Okay, this barrier may be synthetic or natural membrane. There are the either way. The term barrier is applied to the region or regions that offer resistance to the passage of materials. Next, the term membrane is normally used to a film which is separating the phases in our human body or any of the biological system. The materials undergoes the transport is known as diffusion or permeant. That is called the materials which is passing from one barrier to another barrier, one concentration to another concentration is called diffusant or permeant. Okay, this is all about the diffusion principles in biological systems. This is all about the diffusion principles in biological systems. Okay, thank you.